Welcome, everybody. Welcome, Benedicta, Itumeleng, Karabo, Swelihle, and Silindile. Welcome to the class on Saturday. Today, we're going to be continuing our revision on paper 2. And in particular, we're going to be focusing on doing more trigonometry as well as 2D and 3D trig, which is the application of trigonometry. Hope your week has gone well and that you've managed to continue doing some of the homework as well. So yeah, maybe if you could just tell me how you're feeling and also what your views are on 2D and 3D trigonometry. Let's have a look. Oh, some of you are very quiet. Let me know what you're thinking about 2D and 3D trig and how your revision has gone this week. Benedicta, maybe you can let us know. Karabo, Luyanda, Selindile, it would be great to get to know how your revision has gone this week, as well as what your views are about 2D and 3D trig. Thanks for that. Not so confident with 2D trig. Okay. So yeah, trigonometry, it seems as though still seems to be an area that you're wanting to gain more confidence in. And as with all the sections, it's very important to continue your revision regularly, especially now at this stage, looking at past paper questions to consolidate all the theory that you've gone through so far. So yeah, I think let's get into it and start with the question. The first question we're going to look at today is not 2D or 3D trig. It is a trigonometry question from a trig, and then we're going to go on to 2D and 3D trig. What I noticed is that in our last lesson, there were some challenges with the basic trig and the reduction formula and equations, etc. And I think it would be wise for us to look at a question related to that first before we look at any diagrams. Okay, so I'm going to show you and reveal to you what the first question is. Whoops, what is going on here? Let's do this. There we go, right? This is from the 2016 November paper, and some questions are quite different to the ones we've done. It says here, given that sine 16 equals p, determine the following in terms of p without using a calculator. So we cannot use a calculator in this question. We will have to draw a diagram in order to be able to do this question, right? So the first thing we're going to be looking at, whenever they say this question without using a calculator, we know most likely we're going to be drawing a diagram, okay? So without a calculator, most likely using a diagram. So without a calculator, diagram. Okay, so we're most likely using a diagram. And because we've got here sine 16 equals p, 16 is in fact an acute angle. So we're going to be using a diagram in the first quadrant because it is an acute angle. So sine 16 degrees, this one is acute angle, right? So it is an acute angle. And let us draw that diagram. So yeah, just stop me at any stage, or you can unmute or type a message in the chat if it is challenging for you to understand any of the questions. So we first draw a diagram. The diagram would be in the first quadrant. I'm going to draw it freehand, but I'll try my best to make it as neat as possible. And it's going to be here in the first quadrant, right? Like that. And we've got your sine 16 equals p, and I'm going to make it into a triangle. And this is 16 degrees. And we've got p. So what do we know about sine? Sine is opposite over hypotenuse, or it's going to be y over r if you use that method, right? So sine 16 degrees equals to opposite over hypotenuse. And the opposite here would be p, and the hypotenuse would be 1. And then we find the x using Pythagoras. So we're going to say x squared plus p squared equals 1 squared. So x squared equals 1 squared minus p squared. Therefore, x equals to square root of 1 squared minus p squared. So x will then equal to square root of 1 minus p squared. So here at the denominator, we have square root of 1 minus p, denominator, the y-axis, we have square root of 1 minus p squared, right? If you can just show me a thumbs up. Are you okay with this so far? Are you aware of how to find your x and how to plug in the values in the diagram? Welcome, Karen. Welcome, Rusejo. Okay, thanks for the thumbs up, Swelitle. What about the rest of you? Are you familiar with these type of questions? Are you okay with drawing the diagram? Are you okay with finding the x? Let's have a look. Thank you, Itamaleng. Thank you, Benedicte. Thank you, Karen. Okay, so we're going to try the first one now. It says sine 196. I'm going to give you 2 minutes to try that out and tell me what is sine 196 in terms of p. Let's have a look if I've got any answers. You're welcome to type your answer in the chat. That would be really great. Sine 196. Okay, Timoneng's given me an answer. Okay. What about the rest of you? You can share your answers. That will be really great. Mm, okay, yes, I'm seeing a lot of similar answers. So basically what we need to do here, we need to convert the sine 196 into an expanded form that works with this diagram, right? So what we're going to do is, I'm just going to move this across here. So I'm going to say sine 196 degrees, right? That equals to sine 180 degrees, right? Plus 16 degrees. Okay, so sine 196 degrees equals to sine 180 plus 16 degrees. And remember, according to our cast rule, we've got the 180 plus, in fact, gives us a minus because sine is negative in that quadrant. If I just quickly show you here, if we look at our cast rule, once again, CAST, and in the 180 plus, it would be here. And the 180 plus quadrant sine is negative. Hence, it will be negative sine 16 degrees. And by looking at our diagram, what do we know about sine 16? Sine 16 was in fact opposite of hypotenuse, which is p. So it's going to be minus p. And that is our final answer, minus p. Yay, well done. To those of you that got the answer, it is in fact minus p, right? Okay. What about the next one? Cos 16 degrees. What is cos 16 degrees? It's a simple one, this, because we simply look at our diagram. I know it's going to be very difficult to type it in the chat because you have a square root, but we're going to say cos 16 degrees is cos, remember, is adjacent over hypotenuse. So it's simply going to be square root of 1 minus p squared. And the hypotenuse is just 1, right? So it's square root of 1 minus p squared. Is everybody okay with that? If you can just show me a thumbs up with the cos 16. Square root of 1 minus p squared. Yeah, okay, great. Thank you all. Yeah, seems like the diagram. Thank you, Timilang. Thank you, Benedicta, and others also in the chat who type the thumbs up. Okay, so this is quite simple. Draw your diagram, use your diagram to find the answer based on your trigonometric relationships, whether it's adjacent, whether it's opposite, and whether it's hypotenuse, and use that to formulate answers. Okay. Okay, great. So now I'm going to take us to the next one, which says, you are given that cos A minus B equals to cos sine sine. Now remember, this one here is a compound angle formula, right? So this one belongs to the compound angles. Okay. And use the formula for cos A minus B to derive the formula for sine A plus B. So we're going to use a formula for cos A minus B to derive the formula for sine A plus B. I'm going to give you a moment to try this one, and then we're going to compare, right? So I'm going to give you a few minutes. How many marks is it for? It's for 3 marks. Yeah, I'll give you about a few minutes, maybe 5 minutes to try it out, and then we can compare. So yeah, I hope you've got your pen and papers ready. generally for these questions, you could very well be asked proofs, and I know there are some that you are required to learn. So yeah, I hope that you are finding it okay to be able to prove this. I'll still give you a few more minutes and then we can compare. Okay, I think it's time to check. Has anybody gotten the answer? And how are you all feeling about this particular question? Who's got an answer for me? Please show me a thumbs up if you have, or type in the chat, or you can unmute as well. Who's got an answer for me for this one? Okay, that's great. Thanks, Itumeleng. Itumeleng, are you able to unmute yourself?
Yes.
Hi, Itumeleng. How are you doing?
I'm fine, thanks. And you?
Great, thank you. Itumeleng, where do we start with this question?
So first of all, I said sine bracket a plus b bracket equals cos square bracket 90 degrees minus brackets a plus b bracket square brackets.
90 degrees minus a plus b, like that.
Yeah.
Yeah. So sine a plus b equals cos 90 minus a plus b. Okay, what do we do next, Itumeleng?
Then I said, so then I took that 90 degrees and I technically broke it into pieces, and I said cos 90 minus a times cos b plus sine 90 minus a sine b.
So it's like this, cos, and then plus sine here. So you said sine 90 minus a, and then you said sine b here.
Yes.
Okay, and
Then I drew a, well, I got a, so I used your method
yeah.
with the quadrants.
The cos rule. And you converted the cos 90 minus a into?
Sine A,
Yeah.
because it's positive in the second quadrant,
Yeah.
and then cos B plus cos A sine B.
It's plus cos a sine b here, huh?
Yeah.
Yeah. So this is cos a sine b. Thank you for that, Itumeleng. That's excellent. Well done. So I'm just going to go through this again with everybody. So, okay, so we've got here sine a plus b equals cos 90 minus a plus b, and that we use the cast rule for that, right? Remember, 90 minus it changes, it's a co-function. So sine a plus b, sine we can convert to cos, and cos 90 minus becomes sine, right? And then we've got here the a plus b, right? So first of all, sine a plus b equals cos 90 minus a plus b. Then we're going to get rid of this bracket and it becomes 90 minus a. So if I just write it here, this is in fact cos 90 minus a minus b. Yes. And then we just grouped the 90 minus a together and we get this. So it becomes cos 90 minus a minus b. And then this is actually an a minus b situation again, because this becomes the a and this becomes the b. And it's again cos, cos, sine, sine, because it is a compound angle with cos, right? And this is not the same blue. And then we get finally sine a plus b equals sine cos cos sine, right? Yeah, so this is what they wanted us to prove, and we were able to prove it. Yeah. Is this okay, everybody? Any questions regarding this?
So,
Yes.
do you, sorry about that. Do you have to, uh, so you know the writing in purple,
Yeah.
you have to do that step.
It's not necessary. It's not necessary. Yeah, it's just an expanded version. If you're able to do it, the two steps in one, it's fine, as long as you reach the final conclusion. Yeah?
Okay.
So yeah, any questions from anybody regarding this? No questions. Okay, let's move on then to the next one. Simplify 5.3, simplify square root 1 minus cos squared 2a over cos minus a times cos 90 minus 90 plus a. And we need to simplify it. And they also say a is between 0 and 90 degrees, right? So this, it actually simplifies very easily into a number. So I'm just going to give you a tip that this one, not all of them, but this one will simplify into an integer. So if you can just try it out, and we can work towards getting it to an integer value. So let's try that out. Okay, let's try that out. We've got here some of the compound and double angles that we're going to be using, right? Okay, and does anybody have an answer? Please type it in the chat. Does anybody have an answer for this? No. Okay, must be quite a challenging question for you. Let's see if we can ask some people. Asipe, maybe do you have an answer? Asipe? No. Lesejo, any answers from your side? Nope. Okay. What about you, Swelihle? Swelihle, do you have any answers for this question? Nope. Okay. Okay, I'm going to work through it with you. We've got here 1 minus, I'm going to just rewrite this question. 1 minus cos 2a over cos minus a cos a 90 plus a. I think let me write it here on this side so that I have enough space here. What the color should I use? Let's use green. So we've got here cos Seho, you're saying it's 2a over sine A. Okay, we're going to have a look now. So we've got here square root of, okay, this is not a pen, this is a highlighter. So I have to fix this. Let's do this. Square root of 1 minus cos squared 2a over cos minus a times, okay. So yeah, what are we going to do here? We're going to start with saying square root of 1 minus cos squared 2a. Remember our cos 2a rules, right? So I'm going to say here cos 2a equals to, and we had the cos 2a, it gave us a few options, right? And remember, it was 2 cos squared a minus 1. It was 1 minus 2 sine squared a, etc., right? So we had quite a few different options for this. 1 minus cos squared 2a, and that 1 minus cos squared 2a gets converted to sine squared 2a, right? So 1 minus cos squared 2a, so this one here, look at double angle rules. Double angled. Okay, and 1 minus cos squared 2a will give us square root of sine squared 2a. Okay, and then we've got here at the bottom the cos minus a. Remember, we looked at your negative angles when we did trigonometry last. Cos minus a will just be cos a, and then we've got cos 90 plus a will be minus sine a. Okay, so we've got this so far. If you can just look at it and see if you have any questions. then we've got, remember here, the cos squared 2a plus sine squared 2a equals to 1. This was the other formula here. You can use this also to be able to find what the sine squared 2a and cos squared 2a relationship is. So we've got here sine squared 2a equals to 1 minus cos. And that's how we get this. So you can use this relationship as well for finding what 1 minus cos squared 2a is, right? And that is your sine squared 2a. We can use that relationship as well to be able to solve that, right? Okay, great. And now we move on. So square root of sine squared 2a will give us just sine 2a over cos a times minus sine a. Okay. And what do you know about sine 2a? That one there is a double angle formula, and sine 2a is 2 sine a cos a over cos a times minus sine a. Okay, so this one here we have the double angle formula, right? This one here, sine 2a to that double angle formula, right? Double angle formula. And now we can cancel. So we can cancel things now very easily. And we can say that we've got the sine canceling with the sine, the cos canceling with the cos, and our final answer will then be minus 2. Okay, so we've got minus 2 as our final answer. Have you got any questions regarding this? It is not the simplest of questions. There's some complexity to it. So I'm sure you do have some questions. Please do let me know. I think, Lesejo, your answer that you were giving, perhaps you needed to expand your sine 2a. Hey? That's why it's in that form. It needs to be expanded out more. Okay, thanks. Okay, great. So let's look at the next one. There's no questions regarding this one. Okay, we've got here, given that cos 2b equals 3 over 5, it's very similar to the one we did earlier. Cos 2b equals 3 over 5, and the b value is between 0 and 90, which means that it is in the first quadrant. Determine without a calculator the value of each of the following in simplest form. And we are most likely going to be drawing a diagram. I would think that would be best for here. However, it may not be necessary. It may not be necessary to draw a diagram. Okay, so I think I'm going to use a method without a diagram. And yeah, you can also think about what method you're going to use. And yeah, the people who are watching this on the live stream as well, hope that you are making sense of these questions. Yeah, please feel free to try this one out as well, but I'm going to just write some things down without using a diagram and seeing whether without using a diagram it will still work out fine, right? So I'm going to write it below this question. going to say here cos 2b equals 3 over 5, right? Cos 2b equals 3 over 5. But that's 2b, so we're going to use some of the cost rules in order to simplify that, right? So 5.4, I've got cos, now cos 2b equals 3 over 5, but we know 2b tells us about double angles, right? Double angles. Okay, so 2b, this one is double angles. Okay, so it's double angles, and we're going to use some rules for that. Remember, cos 2b, if I write it here on the side, cos 2b is equal to 2 cos squared b minus 1, right? So 2 cos squared b minus 1. And we then simplify this further. So I'm going to say to get, they want cos b. We're going to get cos b as the subject of formula here. See? Okay. So cos 2b, you're going to plug this in here. 2 cos squared b minus 1. I'm going to plug it in the place of cos 2b, right? Okay. So it is going to be 2 cos squared b minus 1 equals 3 over 5. And then it's going to be 2 cos squared b equals 3 over 5 plus 1. Then I'm going to say cos squared b, 2 cos squared b equals to 3 over 5 plus 1 is 8 over 5. And we're going to then find cos squared b on its own, which is going to be 8 over 5 divided by 2. Because we're taking this 2 over. And cos squared b will then be 8 over 5 divided by 2 is, I believe, 4 over 5. And then to find cos b, we're going to say square root of 4 over 5, which is then 2 square root 5 over 5. And that is the answer. So have a look at that and let me know if there's any questions regarding this particular question. As I say, they're not the easiest of questions because there's some complexity to them in terms of changing around the different trig identities. So please do let me know if you do have any questions with this. Benedicta, Caitlin, Karen, do you have any questions regarding this one? This is the first part, 5.4.1. Okay, you're fine. Thanks. Okay, great. Thanks for letting me know. And we've got 5.4.2, they want sine B. So we're going to use the same method to find sine B. 5.4.2, they want sine B, right? So I'm just going to minimize this so you can see the question with this particular answer. Okay, try that out for me, finding sine B using, again, the cos double angle formula, right? And if you just give me an answer for that, that would be great. I'll give you 2 or 3 minutes and we can have a look and see what the answer is, right? So you can use the very same method with cos B and the double angle formula. Just type your answer in the chat once you're done. Let's see. Itumeleng, Swelihle, Luyanda. Do you have any answers for me regarding this?
I have an answer, but I used the method with the diagram.
Did you get Itumeleng?
I got square root 5/5.
Yes, that is indeed correct. Okay, so you use a diagram method, right? Yeah, so you can use the diagram and find the sign using that. Thank you so much for that, Itumeleng. And I'm going to try and use this other method as well, and see how that one works and see whether we get the same answer as you do, Itumeleng. So we've got 5.4.2, and we've got what is it? It was cos 2b equals 3/5. So cos 2b equals 3/5, right? And we're going to say here cos 2b, because this question wants sine, right? Equals 1 minus 2 sine squared b. And I want the sine on its own, right? So I'm going to say cos 2b equals 1 minus 2 sine squared b equals 3/5. Okay. And then I'm going to make the sine squared be the subject of the formula. So I'm going to say 1 minus 3/5 equals to 2 sine squared b. And 1 minus 3/5 divided by 2 gives us sine squared b. Okay, so that gives us sine squared b. And 1 minus 3/5 divided by 2, I believe, is 1/5. Yes, 1/5 equals to sine squared b. And then we square root this, right? To get sine b on its own. So sine b would equal to square root of 1/5, which will then be either 1 over square root 5 or square root 5/5. And that is sine b. Okay. So yeah, let me know if you have questions regarding this one. No questions. Okay, we're going to do the last one before we take a very small break. So the last one is cos b plus 45. Cos b plus 45. And the cos b plus 45, we're going to use a lot of what we have already. So I'm going to minimize this because we're going to use a lot of the information that we have already. Let's try and do this. So cos b plus 45, right? Cos b plus 45. So cos b plus 45 degrees. And that will give us cos, sine, right? So it's cos b cos 45. And then it's going to be, remember this cos, it changes to minus. So it's going to be minus sine. So it's cos, sine, right? And we've got cos b, which we found to be 2 square root 5 over 5. And then we've got cos 45. Remember, it's a special angle. So cos 45 is a special angle, which is square root 2 over 2 minus sine b, which we found to be 1 over square root 5 or square root 5 over 5. And then we've got sine 45, which is square root 2 over 2. And then we simplify this further. So it's 2 square root 10 over 10 minus square root 10 over 10, which just gives us square root 10 over 10. And that is our final answer for this one. So this one here, we use the compound angle formula, right? Compound angles here, right? Okay. Yeah, so this is what I get for this one. I'm wondering if you have any questions regarding this one. Nope. Okay. You're saying you're fine. Okay. So I see we are 10 to 11. I'd like to give you a bit of a break before we go into the next question. In this break, I would like for you to just remain online. Don't log out of the meeting. Just remain online. You can, if your camera is on, you can just switch it off. You can just unmute yourself, which I'm going to do as well. And we're going to be returning at 11 o'clock. If you can just show me a thumbs up that you understand the break. We are coming back at 11 a.m. If you can just show me a thumbs up. I'm just going to type that here as well, just so that we all know what is happening, right? So, yeah. See you soon, and we can start with another question. Enjoy the break, and yeah, please stay on the line, right? Okay. See you soon. Hi, everybody. I'm back. I hope you are too. You can just send me a message in the chat or any sign in the with the thumbs up or anything, just to show me that you are back so that I know we can start. Are you all here? Can you show me a thumbs up if you are here? Thank you. Thank you. It seems like a lot of you are back. Okay, Benedicta, are you back? It's Milang, Karabo, Karen, Lesejos, Lindile, Swelitle, are you all back? Okay, I could see one of the students unfortunately had to leave due to another commitment. So thanks for that. Thanks for letting us know. And now we're going to be looking at a question on the 2D, 3D trig, which is this question here. Okay. I'm going to let me just see what I can do here. I'm going to zoom it in so you can read the question, but I want to still show you the diagram. Let's try this. Okay. AB represents a vertical netball pole. Two players are positioned on either side of the netball pole, points D and E, such that D, B, and E are on the same straight line. Let's have a look. D, B, and E are on the same straight line, right? I always get a bit scared to draw these straight lines in, but I'm going to try today. Don't laugh if I don't get it right, but I'm going to try this line. I always do funny things when I have to draw it. Let's see. Is that the line? Yes, it is. Okay, let's do this. Okay, see, I'm doing strange things again. Let's do this. Let's do this. Yeah, so there's, oh, there. Okay, yeah, I got it right. That's great. Okay, so B, C, and so we've got here, they say that DBE on the same straight line, and a third player is positioned at C. Third player is positioned at C. Okay, so D and E such that DB and straight line. Okay, third player is positioned at C. The points B, C, D, so B, C, D, B, C, D are in the same horizontal plane, horizontal, flat. The angles of elevation from C to A and E to A are X and Y respectively. Okay, we've got that. They've shown it to us in the diagram. And the distance from B to E is K. So B to E is K. All right. So this is your diagram. I'm going to give you one more minute to reread the question. It's so important for you to understand exactly what we're dealing with here, right? Okay. So the first question says, write down the size of angle ABC. Write down the size. You can just unmute or type in your chat and let me know what is the size of angle ABC and what is the reason. Okay, thank you so much, Lasejo. You're back. We're just looking at this question with the 2D, 3D trig. Anybody has an answer for me? What is the size of angle ABC? ABC. ABC is this angle here. What is the size of that angle? Karen, Benedictus, Slindile. Anybody have an answer? Karabo. Yes, great. It is 90 degrees because it's flat with the ground, right? 90 degrees, flat with the ground. 90 degrees, right? So let me erase this and put in there 90 degrees. Okay. Okay. And show that AC equals to K tan Y over sine X. Show that AC equals K tan Y over sine X. I think this is quite an important type of question. So I'm going to give you just a few minutes to try this. We want to find AC, K tan Y over sine X, right? Yeah, you can see AC is, we've got kind of two triangles that I think we're working with here. Let me just show you. I think we're working with this one. Okay, we're working with that triangle. And then we're working with this triangle here. Okay, so these are the two triangles that we're working with. And yeah, we need to see how can we take the one triangle, the orange one, and then put it into the green one, right? So how can we use the information of the orange one and then put it into the green one? So I'd like you to try that and let me know if you get this 7.2. I'm going to give you about 4 minutes to try it out, and then we'll work with it together, right? Please type in the chat if you do get it, so we can work together. Okay, I think that's enough time. Anybody has an answer here? Can just show me thumbs up or type in the chat. Anybody has an answer? Who has an answer for this? Okay, not many of you. Okay, so what we're going to do here, we're going to be using, um, the, let's see, I've got somebody in the chat here. Okay, okay. Thanks for that. It's Itumeleng, maybe if you want to, maybe if you want to tell me what are the first steps that we're going to use here, Itumeleng?
So what I did is I redrew the image
Mhm.
in order to visualize it properly because I'm a kinetic learner, so I need to see what I do. So I said in triangle ABE.
Just hold on. So you said triangle ABE, right? So we've got
Yes.
ABE, right? So I'm going to talk about triangle ABE, right? So
Yes.
let's draw that out. Let's just draw that out quickly. So we've got A on the top, and then we've got B here, and then we've got E, right? Okay, then you must fill in the values, eh? So that's 90, that's Y, and then this one is K, right? Okay.
Yes.
And what do I look for here?
Um, so you look for your SOHCAHTOA,
Yes. Mm-hmm.
which then I noticed that SOHCAHTOA is opposite over adjacent.
So this is the opposite. This is the hypotenuse, right?
Yes.
And this one is the adjacent, right?
Yes.
And what are you looking for here, Itumeleng?
We're looking for AB.
Okay, so we are looking for AB. That's important, right? So we're looking for AB. And why are we looking for AB?
In order to substitute it into triangle ABC.
Yeah, so AB will be like the gateway for us to get there, right?
Yes.
So we're looking for AB because AB is needed in order for you to link triangle ABE to ABC, right?
Yes.
Okay, so AB is needed to link uh, triangle ABE to triangle ABC, right? So, right, so now we need to find AB, and you said we're going to be using opposite over adjacent, is that right?
Yes.
Okay. So we're going to use opposite over adjacent, which is what trig identity?
10.
10. So we're going to use 10, and we're going to say 10 y equals to AB over
Okay.
k, right?
Yes.
Yeah. So AB will equal to K10Y, right?
Yes.
Okay, so we've got AB now. Now we've got AB, which is K10Y. And now what are we going to find?
Now we're going to find what's going to happen in triangle ABC.
ABC. So let me draw that out. So that's triangle ABC. So that's triangle A, B, C. And we've got this is 90 as well, right? And
Yes.
we've got AB, which is K10Y, right?
Yes.
Then we need to find AC. The question wants us to find AC, right?
Yes.
AC, and we've got X here at the bottom. Okay, so how do we find AC?
In order to find AC, what I did was I said AB, which is, so I rewrote the sum down. So I said AB over AC equals sine X.
Okay, so that's the opposite, that's the hypotenuse. That's the adjacent, right?
Yes.
Okay. So we want AC, right? We want AC, and AC we're going to use opposite of hypotenuse, which is sine here.
Yes.
Okay. I'm going to say sine Y equals to AB over AC, right?
Yes.
And AC will equal AB over sine Y here.
Yes.
Sine X, sorry, sine X, I wrote that wrong.
Confused.
Sine X, eh? Yes, it's sine X. That's AB, so it's going to be AB over sine X, right? And we had AB, which is K10Y, right?
Yes.
So AC equals to K10Y sine
X.
X. Yeah, that is it, right? And that's how we find AC. Okay, great. Thanks for that, Itumeleng. That's great stuff. And thanks for helping me find that. Are there any questions from anybody regarding this? So we did two parts, right? We did first triangle ABE, and then we did the triangle ABC. Are there any questions regarding this one? No, no questions. Okay. The next part of it says, so remember we've got now AC, right? We've got AC. It is further given that DAC equals 2x. DAC equals 2x. I'm going to erase parts here because this is obviously becoming very, the diagram has got too much information. So we've got DAC is 2x. DAC is 2x here. And DAC and AD equals AC. Show that the distance DC between the players D and C is K2K10Y. So here also we've got a new triangle that we're focusing on. Which is here. That triangle there, right? Can you see that new triangle that we're focusing on? Let's highlight it. Here. 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 Here, that's the new triangle we're looking at, right? So we've got this new triangle that we're looking at. So you have to think now three-dimensionally, right? Where that angle will be between, it will be at DAC, and that is equal to 2x, as they say. 2x there, right? And we've got these two AC and AD are equal to each other. So AC and AD will both be K10 Y over sine X. Same with here, K10Y over sine X, right? Okay, and yeah, they want us to show that the distance DC between the players D and C is that K10, 2K tan Y. Okay, so yeah, we're going to think now using our trigonometric knowledge, what are we going to do? Just going to give you a moment to look at it, maybe 2 or 3 minutes, and then we'll decide what strategy we're going to use, right? So even before we decide on doing it, we're going to decide on what strategy we're going to use to solve this, right? Okay, so just have a look at it and see. Sorry, I'm just needing to erase parts here so that we have better space to write this answer down. Okay, that's nice. What are we going to use? What do you think? Let's write this down. Let me write things. So are we going to use A, sine rule? Are we going to use B, cos rule? Are we going to use C, Socatua? Are we going to use D, area rule? Those of you that are on the live stream as well, you're welcome to provide some answers as well, and let me know what those what we can use. Okay, so we can use either sine rule, cos rule, Socatua, or error rule. Which one are we going to be using? What do you all think? A, B, C, or D? Still waiting for some of you to let me know what your answers are. What do you think we're going to use? A, B, C, or D? Itimelang has said cos rule. Who are the others? Cylindila says we're going to be using the cos rule as well. Okay. Those who are on the live stream, there is a button at the bottom where you can click on and you can type in A, B, C, or D, right? So Yeah, just have a look at that as well. So we can use sine or we can use cos rule here, right? So we can use either sine rule or we can use cos rule. We can use either of them, sine rule or we can use cos rule, right? So we can use sine rule or we can use cos rule. Cos rule is the one with lots of squares in it. Remember, a squared equals b squared plus c squared minus 2bc cos a. Sine rule, a over sine a equals b over sine b equals c over sine c. So we need to decide, which one are we going to use? So we can use either sine rule or cos rule. We can't really use SOHCAHTOA because we don't have a 90-degree triangle here. And area rule, we don't really know anything about the area, right? They haven't given us that, so we can't really use these last two, right? SOHCAHTOA, maybe if you split the triangle in half, it could work, yeah. But yeah, I would say maybe, yeah, that would be quite a long process. Yeah. So I think let's maybe try sine rule first, right? So I'm going to look at the sine rule first and see what we can use from the sine rule to find these answers. So, okay, so let's do this. So to find answers using the sine rule, we're just going to go back and recap. What is the sine rule again, right? So what is the sine rule? So we've got here sine A. So it's A over sine A equals B over sine B equals C over sine C. Okay, so we've got these. And to find ABC, we found, sorry, in ABC to find DAC, we've got 2x. And I want to find ADC, right? ADC and or ACD, which are both the same, right? So I'm going to say, so in triangle, ADC, I'm going to say angle angle DAC plus ADC plus ACD equals to 180 degrees because it's angles of a triangle, right? And we're going to say DAC, which is 2x plus 2 ADC. Because remember, ADC and ACD are equal to each other. Because the sides are equal, this equals this, right? That's why I say 2 ADC equals to 180 degrees. Then I'm going to say here, 2 ADC equals to 180 minus 2x. And therefore, angle ADC equals to 90 minus x. So ADC is 90 minus x, right? There. This one, ADC, this one's 90 minus x, right? So the whole thing there is 90 minus x, this whole thing. 90 minus x, right? Okay, now we can use that as a foundation to find now DC, right? Okay, we can use that now to find DC. Let me minimize this again for you. Okay, so ADC is 90 minus x. Okay. Okay, so ADC is 90 minus x, and we're going to now find DC. So to find DC, we're going to be using the sine rule. So I think it may be really great to quickly draw that triangle out. So we've got here, here's DC, right? And then we've got A here. This one is 2x This one here is 90 minus x. And here we have 90 minus x. And then here we have k tan y over sine x. Okay. And we're going to solve now. So we're going to say here using the sine rule. Remember, opposite this side here is little a here. Then we have d here. And then we have c here. So using the sine rule, we have d over sine d equals a over sine a. Therefore, we have dc, no, it's not dc, sorry. It's ac over sine 90 minus x equals to a, which is dc, this is what we're looking for, over sine 2x. Because this is sine a, which is 2x, right? Okay. So AC over sine 90 minus x equals DC over sine 2x. Okay. And then we're going to say AC, which is K tan y, right? K tan y over sine x, right? So K tan y over sine x over sine 90 minus x. When sine 90 minus x, remember, becomes cos x. Equals to dc, and sine 2x becomes 2 sine x cos x. Okay, so I've done some important conversions here. I'm just going to circle them. So we've got here AC, which becomes K tan y over sine x. Then we've got sine 90 minus x, which becomes cos x. And then we've got 2 sine x, sine 2x, sorry, which becomes 2 sine x cos x. So we've got these important conversions that have happened here, right? So quite a lot happening at the moment. So I'll just give you a moment to just have a look and see what the conversions are that we've done there. Okay. Then we need to solve for DC. The question wants us to solve for DC, right? So we're going to say DC is going to be our subject of the formula there. So we're going to say DC equals to K tan y over sine x, right? Okay. over cos x times by 2 sine x cos x. Okay, so let's neaten up this part here. This is going to be k tan y over sine x. Just neatening up this part here. Times by, remember this was cos x over 1 at the bottom there. Times 1 over cos x. Times by 2 sine x cos x. Okay, so DC then equals to k tan y over sine x cos x times 2 sine x cos x. Okay. I'll just give you a moment to have a look and see what happened there. Okay, so we've got here DC equals k tan y over sine x cos x times 2 sine x cos x. Okay, so yeah, so k tan y over sine x cos x times 2 sine x cos x. And now what we need to do, we need to see how we can simplify this. We're going to cancel the cos x, change the color. Oh, it's too light. We're going to take sine x, cancel with the sine x, cos x, cancel with the cos x. And we then left with DC equals 2k tan y. So we cancel everything and we got DC equals. Oh, why is this marker so small? Let's fix that. So we've got DC equals to then 2k, because we left with the 2 there, tan y. And we've been able to prove it now because that was what we were required to prove. Okay, are there any questions regarding this one? Let's see. Benedicta, do you have any questions regarding this particular question here that we've done? Itumeleng, Karabo, Karen, Lesejo, Silendile, Swelile. Do you have any questions regarding this one? Of any, how we found the solution or how we use the rules? Okay, right. So Lesejo, we can actually, this is not the only way it can be done. We could have used the cosine rule. I'm not going to do the whole process, but I'm going to just show you how you could have used it, right? So if we were to use the cos rule, we can go back to our triangle here. Here's our triangle that we're using, right? Just going to erase this part here so we can see how we can use the cos rule here, right? Remember, in trigonometry, there's always various different ways in which to do the questions, right? Because we've got so many rules that we can use or rely on, right? Okay. Okay, so we've got here, we've got the cosine rule, which is using DC as our part that we're looking for. So we can say DC squared equals to AD squared plus AC squared minus 2AD times AC cos 2x. Okay, and why is it cos 2x? Because this is the angle that we're looking for. So it is a squared equals b squared plus c squared minus 2bc cos a, and that is the cos angle that we're looking for. So we could use this, plug everything in, and then eventually get the answer. So this one here is using the cosine rule, right? Ooh, cosine. Some of you did say you would like to use the cosine rule. So if you use the cosine rule, you will use something like this and use this method here, right? Okay, is that okay, Lesejo? So you can use the cosine rule as well and plug in all the values and use that as a simplifier. So once you have this, the rest is just doing the correct algebra and getting the answer, right? Is that fine, Lesejo? Okay, okay, that's great. Okay, so those of you that were thinking about cosine rule, this is another method of doing this particular question. This is the only questions we're going to be looking at today. So we're slowly coming to the end of the session. Is there any further questions? I just want to say thank you so much to you for your contributions over the past many days that we have revised paper 2. It's been really great working with you and working through your contributions and your questions. And thank you so much for your dedication. Those of you that I see a lot of names that have attended every single day and every single session. I've really enjoyed working with you, and I really do look forward to seeing you in further sessions regarding grade 12 topics. I'm going to hand you over now to Coco, who's going to be ending off and just giving you some more information about the app yeah, about future sessions for grade 12s. So yeah, good luck with your tests that are upcoming and your exams, and hope to see you in one of the future classes as well. So take care, and yeah, Coco.
Yes, thank you, Teacher Dipesh. This is very informative. I think this will help a lot. I think it'll help you guys a lot in your exams coming up. Thank you so much, guys, for joining us. I know a lot of the kids who are normally with us today are at school, actually doing their own metric review with their classes. So thank you so much for joining us, guys. Again, if you do need any help, we are here to assist. I'm just going to go through everything that we've gone through so far. So these are the 5 lessons that we've looked at over the past week. We have looked at analytical geometry, statistics, Euclidean geometry, trigonometry, and then today was measurement and trig application. All of these, again, are available on our website, and they're available on our YouTube channel if you want to just do a quick review of everything again before you head into the exam. All right, so the homework that we're going to be looking at, again, we're going to be looking at exam revision. Then we're going to go to the 2018 paper and we'll look at questions 6 and 7 from there. They're very similar to what you guys have just done now, but it will challenge you a little bit more. So you guys can have a look at those. The memo is on the app as well. All right. If you can, guys, we will send you a link with a survey for paper 2, and you guys can tell us whether you like the class, whether you didn't, what you want to see more of, what you would like for us to do in the future. From us, guys, for the rest of term 3, this is the last lesson we're going to be having with you guys. We do realize you guys are writing your prelim exams at the moment, so we're just gonna wish you guys the best of luck, and we will then see you all back in term 4, so we can help you guys with your absolute final exams at the end of the year. So this is our last session with you guys. All right, thank you so much, everybody, for joining us today. Again, we are here still to help on the app if you need anything. But yeah, good luck, guys, and bye-bye, everyone.
Good luck, everybody, and take care. All the best.